This is a tricky question which has a trick solution. Here was a semicircular plate which has been cut from the middle. A semicircular plate of radius r1 has been cut from semicircular plate of radius r2. We now need to find out the center of mass of the remaining plate. Now again, we start with the center of mass lies on this axis, as it is the axis of symmetry. So the only thing we need to find out now is the y coordinate of the center of mass. So the first thing that comes to our mind is y coordinate of center of mass is equal to integration y dm upon total mass. So we have to search for the small elements now. Now intuitively, the small element that comes to our mind is a semicircular wire, and we can assume it to be composed of many small semicircular wires. This is one of the solutions, but this solution is lengthier as compared to the solution which I am going to tell you now. In these type of questions, when something is cut out from something, you can do one thing. Let the mass per unit area of this object be sigma. Now you assume a plate of mass per unit length sigma and minus sigma superimposed over it in this region. So in this region, this is practically not true because mass cannot be negative, but this is one of the ways to solve the questions easily. Whenever something is cut out from something, you can use this method. You assume a plate of mass per unit area sigma kept over here, and on top of that there is another plate, semicircular plate of mass per unit area minus sigma kept over it. Now the plate of mass per unit area sigma along with the remaining plate forms a semicircular plate of radius r2 whose mass per unit area is sigma. So what we get now is one semicircular plate of mass per unit area sigma with radius r2, and on top of this we have superimposed another plate of radius r1 and mass per unit area minus sigma. Now we need to find out the center of mass of this combined system. This combined system can be taken to be equivalent to this system because eventually sigma and minus sigma will cancel each other, but this just simplifies our calculation. So now we find out the y coordinate of center of mass. We know that this can be written as m1 y1 plus m2 y2 plus m3 y3 and so on upon m1 plus m2 plus m3 and so on. So by using this formula, we get the y coordinate of center of mass to be the center of mass of this whole plate, the outer plate, that is sigma into pi r2 square by 2. This is the mass of the outer plate into y coordinate of the center of mass. We know that for a semicircular plate, the center of mass is located at a distance of 4r upon 3 pi from the center and above from the center. So we multiply this by 4r2 upon 3 pi. These standard results for center of mass you should always remember for semicircular plate, for semicircular ring and wire, and plus this. Now we write the mass and the center of mass m2 y2 term for this plate. For this plate, the mass is minus sigma into pi r1 square by 2. This is the mass of this plate. I know that the mass cannot be negative, but we write this to be like this just because it helps in our calculation. There is nothing wrong mathematically in it, but there is something wrong physically in it which we ignore because we get the solution the easier way. And the center of mass of this disc is located at 4r1 upon 3 pi upon total mass. The total mass will come out to be the mass of the outer disc minus the mass of the inner disc, that is equal to m. This m can also be written as the mass of this disc, that was equal to sigma into pi r2 square by 2 minus pi r1 square by 2. this is the y coordinate of center of mass of this remaining plate. So on seeing this, we cancel sigma pi by 2 from the numerator and the denominator to get y coordinate of center of mass is equal to 4r2 cube upon 3 pi minus 4r1 cube upon 3 pi divided by r2 square minus r1 square. This can be further simplified to 4 upon 3 pi r2 square plus r1 square plus r1 r2 upon r1 plus r2. So final answer for the y coordinate of center of mass for this object is this distance above this point. This is our final answer.